Open system interconnect. We saw there are 7 layers, and each layer has got a specific function to do. They have specific functions. So we cannot skip any of the function if a device cannot do a particular function. The device cannot send any traffic out. I repeat, we got 7 layers, and each layer has got some job to do. Now, if in case this data link layer if this data link layer cannot provide the MAC address, if this data link layer miss something, then it cannot be a valid packet. The traffic won't go out of that computer. Every layer should complete its job. If one layer don't have the information to attach, then it is not a qualified packet. In another word, it is called as encapsulation failed. Encapsulation means what? You put something and cover it. Like a capsule, tablets. You put something inside and cover it. 7 encapsulation should happen. If not, that packet itself will not be sent out. PC cannot send out. So no problem at all. It's not like, it is sent and then someone ignores. Session layer has to do its job, transport layer has to do its job, network layer has to do. If any one layer cannot provide the info, packet cannot be sent. This top 3 layers operating system determines. Even transport layer is under the control of operating system, but if someone wants to change the default port numbers, etc., they can do it. Transport layer does segmentation, we saw. Transport layer adds the sequence number so that the receiving device transport layer can rearrange the data, and transport layer also does selection of the transport protocol TCP UDP. Whether to use TCP or UDP determined by the application that we used. But the protocol TCP or UDP is selected for use by the transport layer, not by the application layer. Application layer says this is the application from where the data generated. So depending on the application, the transport layer is going to decide. For example, when the customer posts a letter with the acknowledgement, see, the customer has paid for acknowledgement. Once the letter reaches the receiver, to the sender, acknowledgement will be sent by the postal department. See, that service is not for everyone. Not all those who post a letter in the post office gets acknowledgement. Only for those who have subscribed, paid for an acknowledgement. An acknowledgement comes once the letter is delivered to the receiver. Like a registered post. Nowadays you may not know it, but 80s, 70s, 90s people know it. Likewise, if the application demands TCP, transport layer is going to give TCP. If application demands UDP, it's going to be UDP. For one particular traffic, both cannot be used. For one packet, either TCP or UDP. See, some services, they start with UDP and then they change to TCP. That is allowed. One packet cannot be using both. Okay, first of all, let us learn the difference between these two. Then we will discuss which traffic needs TCP and which one needs UDP. You might have heard about this TCP UDP differences many times, but you may not be sure of what it is. If that is how you are, your confusion will be now solved. You see, TCP we learned as connection oriented. UDP connectionless. TCP demands acknowledgement. UDP best effort delivery. Best effort delivery. TCP reliable, and reliable UDP. And TCP compared to UDP slower, UDP compared to TCP faster. We know it already, but what is the real meaning of it? Connection oriented, connectionless. What is the actual meaning of connection oriented, connectionless? TCP, connection oriented. What is the actual meaning of it? TCP demands acknowledgement. That is the actual meaning of the previous one. Connection oriented and demands acknowledgement are the same. Connection oriented and demands acknowledgement are same. Connectionless, best effort delivery are same. So without focusing on the second point, understanding the first point is difficult. Understanding second point will make you understand first point. So without focusing on the second point, how people try to understand is, okay, TCP is used in the cables, UDP is used in the Wi-Fi. I have heard this from a trainer in 2006. One trainer in HCL was telling this. You know what is connectionless? They are used in wireless. TCP is used wherever you have cable connection. Poor guy, poor in knowledge. But he was a trainer in that corporate company. Connection oriented, connectionless is not that. This connection oriented is also seen in wireless. This connectionless is also seen in wired network. Both are seen in both the technology, wired as well as wireless. Then what is connection oriented? When you book a ticket online, you get the flight itinerary as soon as you book. That will say that on this date, at this time, you can board this flight. That you download in your laptop. You booked online, you download. And then now you go with the printout or a soft copy. You go with printout or soft copy, or we also have an app, Digyatra. Today, nowadays, we have an app called Digyatra, Digital Yatra. Digyatra, it's an app actually. You can download in a cell phone, and you can log in and keep your ID in the Digyatra. ID like what? PAN card or whatever it is asking, passport copy, scanned copy. You keep it, in the Dig Yatra. And now when you book a ticket, you get a PNR number. You put the PNR number, that's all. You are done. Now you go to the security counter in the airport, there is no people stopping you if you have this Dig Yatra. Because Dig Yatra has already got your ID in it and the ticket. It has already checked your ID. So there is no police or someone in the military, someone in the gate going to check your ID now. In olden days, like 5 years before Corona period, we used to carry a physical copy of the boarding pass, and we also need to carry one government ID. They compare the name, they see the face, and then they allow inside. Not only that, they will check the date and time of the flight, and then they allow inside the gate, the main gate. I'm not talking about the flight gate, main gate. Now it is not like that. Dig Yatra all over the world. You book the ticket, put the PNR, now the PNR knows that this person is already authenticated digitally. So you need to just keep the QR code and door opens, you go. See? Demands acknowledgement. Because you have added your boarding pass, to the Dig Yatra, as soon as you go with that exact QR code, that becomes an acknowledgement, only then the door opens. Yeah? Door opens only when the acknowledgement is seen. That's the acknowledgement, the QR code that is generated for you. Now, UDP is not like that. Whenever you want, you get into the bus, take a ticket, and you go. Whenever you want, you board a bus, government bus. That too for ladies, it's free. No acknowledgement, nothing. Just go sit wherever you want, you get down. That's connectionless. So no one knows that you're going to come and board a bus. Government don't know, conductor do not know, driver don't know. But when you are boarding a flight, airlines know that you are going to come on so and so date with this acknowledgement, and you will board a flight. So only when seeing the acknowledgement, they allow you inside. If not, no. Same way, before doing the actual communication, before sending the actual packet to the destination, say for example, A and B wants to talk. A, before sending the actual packet, actual data, it will send a synchronization packet, SYN packet, in order to synchronize, in order to establish this connection. It sends what? SYN packet. When the SYN packet is received by B, B will send an acknowledgement. Only after receiving the acknowledgement, sender knows that B is available to receive my packet. At the same time, B is also sending a SYN packet. A has to send an acknowledgement so that B will also know that whatever I send, he is ready to receive. Only when both the side acknowledgement comes, both the side they send SYN packet and both the side they receive the acknowledgement. Only after this, the actual data is transferred. This is what we call it as connection oriented. They demand acknowledgement, both sides. Both party needs the acknowledgement from the opposite party. Only on receiving acknowledgement, they get the guarantee that connection is available between me and B, A and B, and A and B can communicate now. And we call this as three-way handshake. Three-way handshake. We'll talk about in detail in few minutes. Whereas UDP is not like that. If A is trying to communicate to B using UDP, it will send the data, assuming that B is there. But in reality, B may not be there. Maybe there, may not be there. We don't know. That is what we call it as connection oriented. Sorry, connectionless. Yeah. Best effort delivery. It is doing its best. Yeah. Best effort delivery means it's just sending it. Never cross-checking with the receiver whether he is there to receive or not. Connectionless. So TCP is considered to be a reliable communication and UDP is not. But if you see, TCP is slower. Why it is slower? Why it is slower? Because it is sending the SYN packet first, waiting for the acknowledgement. If no acknowledgement, it's not going to send. It will keep sending the SYN packet only till it gets the acknowledgement and then send the data. Even while sending the data, it will stop randomly. It will stop randomly and send again the SYN packet to make sure the connection still exists. And then send. See, this is all in the middle, no? Disturbance caused to the communication, which is slowing down the communication. Every now and then it will stop and check the connectivity by sending SYN packet, waiting for acknowledgement. That's why it is slower. In UDP, you don't have such mechanism. It keeps sending all the data, hoping that receiver is there to receive it. Now you may think that then why are we using UDP? TCP is reliable. It's reliable. After checking, you send. After checking, you send. This is highly reliable. Why are we going to use the unreliable one? That's not the story actually. Both are important. Both are important. We all love to eat home food, homemade food. That is reliable. But it is slower. Getting food online takes less time than you cooking a food. But still you buy sometime, no, when you are sick, when you are busy with some other important work. We still use that online restaurants. Though it is unreliable, knowingly we use it. In food itself you are ready to use. Why not in networking? TCP is used wherever reliability is must. Wherever you are ready to compromise with the speed. More than speed, what is needed? Reliability. Those applications will be given, those data from those applications will be given TCP. Other applications which are not that focused on reliability but focused on time sensitive traffic, those time sensitive traffics, they use this UDP because they are time sensitive. They want fast communication. Even though it is unreliable, applications use it because they want fast communication. For example, I am talking to you for the last 30 minutes and the filler that I am using also you are able to hear from me. That filler, even those things you are hearing. Actual word that I am saying also you are hearing. You are not interpret for some time and then again hearing and then again stopped. You don't have something like that. Continuously you are hearing, which means what? UDP is in place. Right now this class is happening because of UDP, not because of TCP. This online class is happening because of UDP. Streaming videos and audios. That's what we are having now. The streaming videos and audios. Okay, they need UDP. They use UDP. Streaming, WhatsApp, Messenger, Facebook Messenger, or any other messenger. They all use UDP. Yeah, it is unreliable, but for those communication, fast is needed. Instant messenger. Can't use TCP. the mails that you send, the file that you transfer, for those things reliability is needed. It's not that time sensitive. There TCP is used. Right? Example, file transfer protocol, telnet, SSH, HTTP, all those things. Uses what? TCP. As I said, voice, video, all messenger, internet messenger, and a lot of protocols, like there is a routing protocol called RIP that uses UDP. All multicast traffic uses UDP. There's a protocol called real-time protocol. Uses UDP. This is what voice protocol, real-time protocol. Okay, so both are necessary. It's not like this is bad and that is good. Both are necessary. You want to drink a juice, but what to do? Juice is not available. At least water you can drink. You can't hate water. Without water you can't get juice. Both are needed. Not always juice is good. You also need to drink water. UDP, TCP, both are important. Without UDP, we can't have this class, I'm telling you. Okay, now let us talk about this three-way handshake. To understand this connection oriented one more time, let's talk about this three-way handshake. A and B want to communicate. So A sends a packet. With a sequence number 300. It is sending a SYN packet. This is called synchronization packet. See, acknowledgement is null there. SYN packet. And this is not the data actually. It is just a garbage value, dummy data, with a sequence number sent to B. If B is there available to receive it, and if B is there capable of receiving it, B will send acknowledgement. And I told you B also want to talk to A, no? Both want to talk. So B is sending its SYN packet. Along with the acknowledgement. This is just a SYN. This is SYN comma ACK. SYN-ACK. We used to call it a SYN-ACK. I'll capture a packet and show you in some other day. It's called SYN-ACK. And then for the SYN that is coming, A will respond back with the ACK. This is what called as the three-way handshake. both have acknowledgement from the opposite party. This guarantees that both are in a position to receive one another data. You see, this 301 is an acknowledgement for 300. Only if B receives the 300, it can send the number very next to that number. Forward acknowledgement. So on receiving, A understands that B has received my 300. That is why he is asking for 301. Likewise, when 701 is sent by A, B understands that A received my 700. That's why he is asking for 701. This is what called as forward acknowledgement. Sin, synac, ac. Sin, synac, ac. This is what we call it as connection oriented, demands acknowledgement, three-way handshake. Is there any question? Next is in transport layer, port numbers are assigned. Port numbers. What is port number? In an easy understanding term, I'll say port number is a number given for a service. If you go to a chocolate, cool drinks vending machine, it's there everywhere now. In offices they have, in airport they have. I'm not sure about the bus stand and all. I have never gone for many years. I have not seen in a railway station. I have not seen. But in airports, in offices, we have this vending machine. If you want Coca-Cola, which is here, and I want this Coca-Cola, they have a label here. I need to press the number. There will be one keypad here. I need to press the number. Then a QR code will come. I scan the QR code and I pay. As soon as I pay, this will roll down and fall down. There is an opening here. I can take it. So whenever I need Coca-Cola, I need to put the number that they have written here. Let's say first row, second row, third row, 301. 301. Now, if I want Fanta, which is here, it's 205. So whenever you press 205 and pay the money, you will only get Fanta, you will not get Coca-Cola. Coca-Cola is everywhere, even in Taliban, Afghanistan. It's world famous now. Yeah. Coca-Cola, 301. Fanta, 205. So to get the product, you don't type Fanta, give me. No. You don't need to say that Fanta, give me. Coca-Cola, give me. Put the number and scan the QR code, pay it, it's going to give you the product. The products are labeled. To identify the product, a number is given. Likewise, to identify the services in network, numbers are given. Example, I am demanding a telnet. I want a telnet. 23. Actually, I am going to another device and say, hey, I am expecting a telnet. Remotely, I want to log into your device. Open the door, telnet door, open the telnet door. How will I say that? I say 23. The receiver understands that I'm asking for telnet support. When I go with the port number 21 or 2021 is for FTP. So receiver understands that I am asking FTP support. When I go with the port number 443, I am asking for HTTPS, a secured HTTP. When I go with the port number and say 80, the receiver understands that I am looking for HTTP. When I go with the port number 22 to the receiver, receiver understands I am looking for SSH. See how the port numbers are used. Used to identify the network services. Now, based on the application that you used to generate the traffic, the transport layer allocates, assigns the port number to every segment. I told you transport layer will segment the data so that it can be easily carried. So to each segment, not only it adds the sequence number, along with that it also adds port number. Port number is what going to tell the receiver what the sender is looking for. And for this port number, 16 bits are reserved. In 16 bit, you can have port number between 1 to this much, 1 to 65536. With this 16 bit, you have these many port numbers, but one to 1023 is what reserved for services like this. "23" means always tell it. These are reserved port numbers. Other than these, from 1024 onwards to 65536, anyone can use for a lot of purpose, port forwarding, or you are developing a software and you want to provide a port number, you can provide a port number and that will be used internally. That's your company software. So reserved port numbers are only 1 to 1023. 1024 onwards to 65536. It is used in various places for various purpose. Sometime, there may be two applications using same unreserved port number, like a game, online game. For that, we need to go and change the port number. If you have two applications having same port number, unreserved port number, you need to go to one of the application to change so that it won't conflict. So the port numbers are given to each segment by the transport layer. Now there will be two port numbers transport layer adds. One is source port number, another one is destination port number. For example, A is telnetting to B. So in the transport layer, A will put a random source number as the random port number as the source. Sender no. So can be any number. But because it's a telnet, the destination should not be anything other than 23. Source can be anything. When it goes to B, it should say, hey, I'm looking for 23. Coca-Cola. Telnet. B understands that A wants a telnet. So whoever initiates, no, they will always send the source port number, a random port number. It won't be less than 1024. It will be always greater than 1024. Okay. That's about the transport layer. Transport layer, what all we have learned? It is responsible for transportation according to the capacity of the wire, the media through which we communicate. The segmentation happens, and also its sequence, and also it decides whether to use TCP or UDP. It also allocates the port number depending on the service that we are looking for, and always the source port number will be a random port number. Now when B responds back, source port number will be 23, destination port number will be 333. That is done by B's transport layer. This is response packet. This is sender, initiator, response. Any question on transport layer? Right. In network layer, as I said earlier, the source and destination IP will be attached. If A is in 10.0.0.1 and B is in 10.0.0.2, if A and B are talking, then the source port number is going to be, source IP is going to be 10.0.0.1 and destination IP will be 10.0.0.2. And when B responds, source will be 10.0.0.2, destination will be 10.0.0.1. This IP address is 32-bit size. Network layer, not only IP we also have IPv6. I told you in the previous class. Before this, we had something called IPX, Apple Talk. But those things are no more. We have IPv6. Even some routing protocol also works in this network layer. Layer 3. In network layer, protocol like OSPF, EIGRP works here. About these protocols we'll talk later. About the IP address also we'll talk later. But one main thing we should know from here now is network layer is responsible for giving source and destination IP. Next is the data link layer. Layer 2. This is responsible for picking up the right protocol to encapsulate. If it is Ethernet wire, then Ethernet. If it is a serial wire, HDLC or PPP. If it is fiber channel, then FC. Not only that, main thing here we need to know is the source and destination MAC address. MAC address is 48-bit size. And at last, it is sent in the physical layer as bits and bytes. So this is on the sender side. Now the receiver is receiving it. It receives in the physical layer and it checks the destination MAC address of the packet. If the destination MAC address matches with B, then B opens the packet further. It checks the IP address in the network layer. If the IP address of the incoming packet is matching with B's IP address, then B understands it is for me. It opens further. In the transport layer, port number is mentioned. If that port number is open, then it is going to open further, change the session ID, and from the presentation layer it understands that it's a telnet, and the application that is running inside for telnet support starts supporting. So the data which is sent from A is seen here by B once the packet comes out of this layer. On A side, from top to down, encapsulation happened. Here it is decapsulation. Sender encapsulates and sends. Receiver decapsulate and check whether it is for the receiver. If it matches the MAC address and IP address, opens and then knows the information. And if there is necessary to respond, it will respond. This is how the communication happens. It is not focusing on sender is sending from Windows, I am in Mac, I should not open, nothing like that. You may use Windows or Ubuntu or Microsoft Windows or Mac, whatever. They don't care about all those things. All they care is the 7 layer. Whether you use an Apple phone or an Android phone, doesn't matter. For communication, that doesn't matter. They only look for the 7 layers. If that is there, communication happens. Any question on OSI layer? You're good? It's a very important topic, though it is very popular and it's really very important. In our next class, we are going to learn about ARP, and then we'll get into DNS, understanding how DNS works, ARP works, and then how IP address and MAC address both are important. That's what it's going to be our next class. I'll stop here for today.